This is SpaceTime Series 22, Episode 48. Coming up on SpaceTime, Curiosity detects unusually high methane levels on Mars, the new mission to explore the Martian moons Phobos and Deimos, and the discovery of cold quasars, which could help explain how galaxies die. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Curiosity rover has detected the highest methane levels ever detected on the red planet. The car-sized six-wheel rover found methane levels of 21 parts per billion units by volume in the Martian atmosphere. Scientists say it's an important discovery because biological activity is the primary source of methane production here on Earth. However, scientists aren't looking for Martian cows, at least not yet. You see, methane can also be produced through geological processes, such as when water dissolves some types of rock. The new findings came from the rover's SAM, or Sample Analysis at Mars Tunable Laser Spectrometer. Curiosity doesn't have instruments that can definitely say what source the methane is from, or even if it's coming from a local source within Gale Crater or elsewhere on the red planet. SAM Principal Investigator Paul Mahaffey from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says scientists can't even tell if the methane source is biological or geological, or even if it's recent or ancient. The Curiosity team have detected methane many times over the course of the mission. Previous studies have documented how background levels of the gas seem to rise and fall seasonally. They've also noted sudden spikes of methane, but the science team knows very little about how long these transient plumes, as they're being called, last, or for that matter, why they're different from the seasonal patterns of methane. Scientists have now organised a different experiment for this weekend, designed to try and gather more information on what they believe is a transient plume. Whatever they find, even if it's an absence of methane, it'll add context to the recent measurement. Curiosity scientists say they need time to analyse these clues and conduct more methane observations. They also need time to collaborate with other science teams, including those with the European Space Agency's Trace Gas Orbiter spacecraft, which has now been in its science orbit for a little over a year without detecting any methane. Combining observations from the surface and from orbit could help scientists locate the source of the gas on the planet's surface, and also understand how long it lasts in the Martian atmosphere. And that might well explain why the Trace Gas Orbiters and Curiosity's methane measurements have been so different. I'm Stuart Gary. You're listening to SpaceTime. Japan has announced plans to send a sample return mission to explore the Martian moons Phobos and Deimos. The Japan Aerospace Exploration Agency JAXA will launch the mission in 2024, achieving Mars orbit insertion the following year, with samples then returning to Earth in 2029. The Japanese Martian Moons Exploration or MMX mission will also carry a German-French-built rover, which will land on either Phobos or Deimos and explore the surface in detail for several months. The rover will be developed as a joint effort between the German Space Agency DLR and the French Space Agency CNES. DLR will be responsible for developing the rover's chassis, robotic locomotion system, and its spectrometer and radiometer science instruments. These will be used to determine the characteristics and composition of the moon's surface. Meanwhile, CNES will develop the rover's camera systems, which will be used for spatial orientation and exploration of the surface, as well as its central service module. The MMX mission will follow in the footsteps of the Hayabusa 2 spacecraft, which is currently exploring the asteroid Ryugu. You're listening to SpaceTime. I'm Stuart Gary. Astronomers believe they may have found Snoopy, the Apollo 10 lunar module. The spacecraft was jettisoned after completing crucial practice maneuvers 50 years ago. Named after the lovable Peanuts cartoon dog Snoopy, it was used for a practice run for the Apollo 11 lunar landing, with 2 of the 3 astronauts transferring into it from the command module and descending down to an altitude of just 15,240 meters, that's 50,000 feet, above the grey, cratered lunar surface. They then rendezvoused back with the command module, successfully docking and transferring back into it. Now, these are all tasks which seem fairly standard now for spaceflight, but were groundbreaking at the time. And it was these maneuvers which helped pave the way 2 months later for that historic manned lunar landing by the crew of Apollo 11. After completing its mission, Snoopy was undocked from the command module and set adrift on a broad solar orbit, and was thought to have been lost forever in 900 million kilometres of space. But now astronomer Nick Howes from the Royal Astronomical Society believes he may have spotted it. Howes and colleagues began their search back in 2011 using the Forks North Telescope in Hawaii, the Forks South Telescope at the Siding Spring Observatory in Australia, together with data from the Catalina Sky Survey in Arizona. Then last year, during observations at the Mount Lemmon Observatory, also in Arizona, the authors detected a small Earth-crossing asteroid catalogued as 2018 AV2. This object orbits the Sun once every 382 days, spending most of its time trailing the Earth. Now, interestingly, 2018 AV2 has an orbital inclination differing from that of Earth's orbit around the Sun by just 1 degree, and its orbital speed is less than a kilometre per second relative to Earth's orbital velocity. Add to that suspicion by the International Astronomical Union that AV2 was some sort of artificial object, and calculations by scientists at NASA's Jet Propulsion Laboratory that this object would have been roughly where Apollo 10 undocked from Snoopy 50 years ago, and Howes is fairly certain he's found Snoopy. To find out more, Andrew Dunkley speaking with astronomer Dr. Fred Watson.
The Snoopy module. Now, this was Apollo 10, wasn't it?
Yeah, that's right. Apollo 10, the mission that, not surprisingly, immediately preceded Apollo 11. And it was basically a test run for the Apollo landings in July 1969, the first Apollo landing in July 1969. Apollo 10 flew a little bit earlier the same year, and it did the whole deal, went to the moon, but didn't land. So what happened was the spacecraft orbited the moon as planned, and exactly as they did in Apollo 11. Of course, the Apollo spacecraft were in several modules. The command module, which was the conical bit, which actually is the only bit that came back to Earth. The command module on Apollo 10 was named Charlie Brown, after the cartoon character. And so the lunar module, the bit that went down to the lunar surface, had to be called Snoopy because that was Charlie Brown's dog. So it did all its stuff. It followed all the protocols, touched down to within 50,000 feet of the lunar surface, which was the point at which normally the descent module would kind of kick in its rockets and start the touchdown procedure on the lunar surface. But instead of doing that, what they did was they mimicked the return flight from the lunar surface to the command module, which of course was in orbit around the moon, so that the upper part of the lunar module was basically what brought them back to the command module. The lower part of the lunar module actually crashed on the moon. That eventually crashed on the moon. But the upper part, the bit that carried the astronauts, having docked with the command module and the two astronauts who were Tom Stafford and Gene Cernan transferring back into the command module, namely Charlie Brown, what NASA did was fired the engine of the lunar module, Snoopy's engine, to take it out of lunar orbit and basically put it into orbit around the sun.
Oh, wow.
And there was no real reason to keep going with this, so they essentially forgot about it. And having done that, nobody really thought about it anymore. The mission continued according to plan. The astronauts came back to Earth in that beautiful dress rehearsal for Apollo 11. It's only, I guess, recently that people have started thinking, I wonder what happened to Snoopy. And in particular, an amateur astronomer, although he's a fellow of the Royal Astronomical Society, the peak body in the UK, he has done a lot of work on trying to work out where Snoopy is, partly in terms of calculating, whereabouts it might be given the orbital parameters that we know about Snoopy in its orbit around the sun, but then trawling through all the data on the web, which comes from the world's big telescopes. Because basically when you do a survey, for example, the RAVE survey, even though that was on stars and the intimate details of stars, the results are now all publicly available on the World Wide Web, on a RAVE website hosted in Potsdam. So the same is true with all the big telescopes of the world. The data are effectively public now. And so Nick Howes, the amateur astronomer who's led this project, has trawled through all that stuff to find evidence of a slowly moving object, a faint, slowly moving object in the right part of space, and says he is 98% convinced that he's found it.
So where is it?
Well, it's kind of in orbit around the sun.
So it is in orbit around the sun, he thinks.
Yes, where it ought to be. That's right. Actually, Nick Howes must be a mathematician of some note, because he estimated the odds of locating the module were 235 million to 1.
Wow.
So he's 98% convinced that he's found it. That it would have needed, you could limit it to a certain part of the sky, just knowing the parameters of what an orbit is. It takes a year for an object in an orbit around the sun to go around once. They trolled through all this stuff and convinced they've located it. The problem is, how do you prove it?
Yep.
This is really difficult. There's not an obvious way to do it because this is a small object. It will come relatively close to Earth, but you've kind of got to wait for that to happen. And maybe the best bet would be radar observations. We often find images of asteroids, near-Earth asteroids, which have been made by some of the big radio telescope dishes in the world. You can use them as radar scanners, basically, and probe the surface of something like an asteroid. But this is much smaller. This is 3 or 4 meters across at most. It's not asteroid-sized. I think what is perhaps at the back of this team's mind is that maybe, just maybe, one of these extraordinarily wealthy space enthusiasts like Elon Musk or Jeff Bezos might just mount a mission to send a spacecraft with a camera on board to have a look.
Yeah, maybe.
It would be fantastic.
Yeah. What sort of condition would it be in now?
It should still be pretty good. It would, it's got 50 years of bombardment by the sun's radiation and by the solar wind. But that takes many thousands of years to make any real difference to a metal surface. So I think it would be in pretty neat condition, actually. There is a nice quotation from the person who's led this project, Nick Howes. He's spoken actually to Gene Cernan. Now, I think Gene died a couple of years ago. What Nick Howes has said is, I would love to get Elon Musk and his wonderful spacecraft up and grab it and bring it down. And then he goes on to say, as Apollo 10 crew member, Eugene Cernan said to me, son, if you find that and bring it down, imagine the queues at the Smithsonian.
Yes, yes, indeed. Yeah, no, it would be amazing, but very, very costly project, I would think. So
yeah, it would be for what amounts to space archaeology. This falls within the province of now called space archaeology.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Astronomers have written a new chapter in how galaxies die. Researchers have reported the discovery of what they're calling cold quasars. These are galaxies featuring an abundance of cold gas that can still produce new stars despite having an active supermassive black hole or quasar at their centers. The breakthrough, announced at the 234th meeting of the American Astronomical Society in St. Louis, overturns assumptions about how galaxies mature and may represent a new, until now unknown phase in a galaxy's life cycle. Quasars are powerful beams of energy and matter generated by supermassive black holes millions to billions of times the mass of our Sun. Material falling onto an accretion disk surrounding these monster black holes is crushed and torn apart as it collides with other material on the disk. While most of this material is destined to eventually pass a point of no return called the event horizon and then fall forever into the black hole singularity, some of the superheated material is instead caught up in magnetic fields before reaching the event horizon. It's then channeled into powerful beams jetting out perpendicular to the accretion disk at close to the speed of light, shining as incredibly bright beacons visible across the universe. Quasars are usually only found emitting from supermassive black holes in galaxies in the early universe, when they still had plenty of material to feed upon. And once the matter surrounding the supermassive black hole is consumed, the quasar becomes inactive. The study's lead author, Assistant Professor Alison Kirkpatrick from the University of Kansas, says quasars have long been thought to signal the end of a galaxy's ability to produce new stars. She says all the gas accreting into the black hole is being heated, giving off X-rays. Kirkpatrick points out that the wavelength of light that an object gives off directly corresponds to how hot it is. For example, humans give off most of their light in infrared. But something that's giving off X-rays must be one of the hottest things in the universe. This gas starts accreting onto the black hole and begins moving at relativistic speeds. Magnetic fields are also generated in this gas, and they can get all twisted up. In the same way you can have solar flares blasting out from the sun, you can also have jets of material going up through these magnetic field lines on black holes and then blasting out into space. These jets essentially choke off the gas supply of a galaxy, and with no more gas falling onto the galaxy, it can't form new stars. After a galaxy has stopped forming new stars, astronomers describe it as a dead galaxy. But Kirkpatrick's survey has found that about 10% of galaxies hosting accreting supermassive black holes also had a supply of cold gas remaining after entering this phase and were still making new stars. She says these included all different types of galaxies. Some had obvious merger signatures, others looked more pristine like the Milky Way, with distinct spiral arms, and still others were very compact. From this diverse population, the authors found a further 10% that were really unique and totally unexpected. They were all very compact blue luminous sources. In fact, they looked exactly like what a supermassive black hole would look like at the end stages of its existence after it's quenched all the star formation in a galaxy. These objects are clearly evolving into passive elliptical galaxies. Yet Kirkpatrick and colleagues found lots of cold gas in them as well, hence the name cold quasars. The authors suspect cold quasars represent a brief yet-to-be-recognized period in the end phases of a galaxy's lifespan. The galaxies are rare because they're in a transition phase, right before star formation in the galaxy is quenched. Kirkpatrick and colleagues identified their cold quasars in data from a region of the Sloan Digital Sky Survey, the most detailed digital map of the universe available. They then examined this region, known as Stripe 82, using the XMM Newton X-ray Space Telescope and with the Herschel Far Infrared Space Telescope, looking for dust and gas in the host galaxy. Scientists already know that quasars go through a heavily shrouded dust-obscure phase, where dust is surrounding the supermassive black hole in what they call a red quasar phase. But this unique transition showed luminous quasars had a blue optical colour, but still with lots of dust and gas, and that's simply not what they should look like. Kirkpatrick thought the growing black hole, which is enshrouded in dust and gas, simply began blowing material away, becoming a luminous blue object. It was assumed that once the black hole had blown out all its own gas, it would blow out gas from the rest of the galaxy as well. But it seems that's not the case. They haven't yet blown out all the dust and gas in their host galaxies, and this cold quasar transition phase could last another 10 million years. Next, Kirkpatrick wants to determine if this cold quasar phase happens in all galaxies, or whether it's just specific to a particular type of galaxy. This is SpaceTime. I'm Stuart Gary. A new study suggests symmetry is not possible when gravity is combined with quantum mechanics. For ages now, physicists have been searching for an elegant set of laws in nature which can be quantified by symmetry. It's thought that these symmetries may be hidden in our world, but should manifest themselves at a more fundamental basement level. However, the director of the Kavli Institute, Hiroshi Oguri, says his new research suggests that this expectation is wrong once gravity is taken into account. Oguri says there are 4 fundamental forces of nature: electromagnetism, the strong nuclear force, the weak nuclear force, and gravity. However, Albert Einstein's general theory of relativity tells us gravity isn't a force, but rather the effect of mass on spacetime. And gravity is the only one of the 4 still unexplainable at a quantum level. Researchers have long believed that an idea known as holographic principle is an important hint to combine gravity and quantum mechanics successfully. A hologram makes 3-dimensional images pop out from a 2-dimensional screen. In the same way, the holographic principle allows physicists to study gravitational systems by projecting them onto a boundary which surrounds the entire universe. This new study, reported in the journal Physical Review Letters by Oguri and co-author Assistant Professor Daniel Harlow from the Massachusetts Institute of Technology, shows that symmetry is simply not possible in a gravitational theory if it obeys the holographic principle. Previous work by Harlow and colleagues found a precise mathematical analogy between the holographic principle and quantum error correction codes which protects information in a quantum computer. This new work shows that these sorts of quantum error correcting codes are simply not compatible with any symmetry, meaning that symmetry would not be possible in quantum gravity. Their findings have important consequences, including the existence of magnetic monopoles, and that protons are stable against decaying into other elementary particles. I'm Stuart Gary. You're listening to SpaceTime. Canada's RadarSat constellation has been successfully launched into orbit aboard a SpaceX Falcon 9 rocket. The Falcon 9 launched in thick fog from Space Launch Complex 4E at the Vandenberg Air Force Base in California.
Falcon 9 is clear for flight. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. Lift off of the Falcon 9.
Vehicle is pitching downrange.
Stage 1 propulsion is now.
Powering telemetry now.
Falcon 9 had an on-time liftoff through the fog
signal
from Vandenberg Air Force Base, approaching max Q.
Vehicle is supersonic. Vehicle is passing through maximum dynamic pressure.
We now have 3 events coming up in rapid succession. main engine cutoff, stage separation, and second engine start 1, or SES1. Main engine cutoff, this is where all 9 engines of F9 will shut down. Trajectory is looking good.
Miko.
Stage separation confirmed.
Main engine cutoff, stage separation, and second engine start 1. So boost back burn has begun. Fairing deployment. We have about 10 seconds left in the boost back burn. Confirmation of boost back shutdown. So in order for the first stage to make its way back to Vandenberg Air Force Base, it has to execute a series of 3 burns. The first is what we call the boost back burn, and that helps to slow the rocket down and orient it for entry. Shortly after this, the grid fins, articulating as they help steer the rocket back to Vandenberg, those are deployed to help guide the rocket during its descent. Following that, Falcon 9 executes its entry burn, and that slows itself down before hitting the dense part of the atmosphere. The entry burn actually cuts the first stage speed almost in half. So that's what will be coming up next at about the T+6 minute mark. The third and final burn that Stage 1 will execute today is the landing burn. Happens to be everybody's favorite burn, and that takes place just before touchdown as the booster touches down softly on the ground. So if you happen to be in the greater Vandenberg Air Force Base area, I recommend that you head outside because you are very likely in range to experience the sonic boom that comes with re-entry. We have confirmation that MVAC power is good. Trajectory is looking good.
Stage 1 entry burn has started.
Confirmation that Stage 1 entry burn has started. We have confirmation of Stage 1 entry burn shutdown.
Stage 1 FTS is safe.
Stage 1 transonic.
Stage 1 landing burn has started.
Landing burn has begun.
Landing legs have deployed.
Okay, Falcon 9 has landed back at Vandenberg Air Force Base. So with that good news, we turn back into second stage, our primary mission, as it continues to carry the 3 RadarSat constellation satellites to sun-synchronous orbit. And there we had confirmation of second engine cutoff, or SECO. So now we're just going to wait for confirmation of second stage good orbit.
GNC confirms good first orbit insertion.
All right, we have confirmation that we have a good orbit for second stage.
The Canadian Space Agency RadarSat constellation mission consists of 3 identical C-band synthetic aperture radar Earth observation satellites. They're designed to support all-weather maritime surveillance, disaster management, and ecosystem monitoring for the Canadian government. The 1,400-kilogram spacecraft were deployed into a 600-kilometre high orbit. The Falcon 9 first stage then returned to Earth after the mission, successfully touching down at the Vandenberg Air Force Base landing zone number 4. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that smoking dope while pregnant increases one's risk of having a preterm birth or other complications. The Canadian study, reported in the Journal of the American Medical Association, involved some 661,617 women, 9,427 of whom were cannabis users. The study found using dope while pregnant doubled the risk of preterm birth from 6% in non-users to 12% in users. Cannabis users also had an increased risk of placental abruption, of giving birth to an underweight baby, of their baby requiring neonatal intensive care, and of their baby having lower general health. A new study has confirmed that Himalayan glaciers are melting much faster than before. The findings, reported in the journal Science Advances, are based on more than 40 years of satellite data. Scientists also found that glaciers have now lost more than half a metre of ice every year since the year 2000. That equates to around 8 billion tonnes of water melt per year. The authors say rising temperatures caused by global warming mean glaciers are now shrinking at a faster rate than at any other time in recent history. New satellite data has revealed the alarming extent of the current drought devastating parts of Australia. The data, using software developed by the Australian National University, found parts of New South Wales, Queensland, Central South Australia, Tasmania and much of Western Australia were drier in December 2018 than during the Millennium Drought, which ended in 2009. The Millennium Drought, which lasted from 2001 to 2009, is considered by many to be Australia's worst drought since European settlement. But this new data from NASA's GRACE and GRACE follow-on satellites shows that there was less water in the landscape of northern and northwestern New South Wales and southwestern Queensland in 2018 compared with 2009. The data also showed dramatic declines in ice levels in Antarctica over the past decade. Scientists found the ice loss in the Totem Glacier region east of Australia's Casey Station amounted to around 1.4 billion tonnes of water. That's enough to have filled around 570,000 Olympic-sized swimming pools. They say the destabilisation of the ice sheet in that region could affect global sea levels by many metres. A new study has confirmed that audible and potentially annoying indoor low-frequency noise from wind turbine farms is present for about 16% of the time at distances of up to 3.5 kilometres from the turbines. The noise, described as thumping or rumbling, technically referred to as amplitude modulation, is related to the frequency of the turbine blades passing the tower and the power outputs of the wind turbines themselves. The study, reported in the Journal of Sound and Vibration, was conducted in South Australia as part of a wide-ranging investigation into wind turbine noise and sleep. Well, scientists already know that bees can understand the concept of zero and they can do basic maths. But now a new study shows their tiny insect brains may also be capable of connecting symbols to numbers. The discovery, reported in the Proceedings of the Royal Society Bee, sheds new light on how numerical abilities may have evolved over millennia. Researchers suggest it may even open up new possibilities for communication between humans and other species. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.